Yes, I think my screen is visible to everyone. Okay, fine. So, okay. So, in the last lecture, we were talking about register reference instruction. Let us have a quick, fast revision of memory reference instruction, and then we'll discuss again. Yes, memory reference instruction. As per the instruction format, we are having 16 bits of instruction size, wherein 0 to 11 are for address in memory reference, 12 to 14 for opcode, and 15th is the I bit, that is direct addressing or indirect addressing. Now, in that case, let me again mention what is actually memory reference instruction. In memory reference instruction, we are actually doing some operation onto the operands available onto the memory. So that's why we are mentioning the address part. That means this operation, this instruction, whatever we'll be discussing, we have discussed, will be operated on the operand available at the address, whether direct address or indirect address. So this is the scenario. So these are the instructions which we are seeing. AND, add, LDA, STA, BUN, and BSA, ISZ. So these were the 7 instructions which we had seen. Now the code for these 7 instructions were starting from 0 to 6. And later on, this was for direct addressing. The same thing, if we change this particular bit, that is I bit, to 1, then again we get the same instructions but with indirect addressing. So 1000, again 1001, that is 9, then A, then B, then C, then D, and E. Let me again remind you that this code, the first column, indicates direct addressing, and these codes are for direct addressing for this instruction, AND, add, LDA, STA, BUN, BSA, ISZ respectively. And the another code which are also mapped to the same instruction, that is 8, 9, A, B, C, D, E, actually they are nothing but indirect addressing. But instruction remain as it is, AND. This code will perform AND operation only, but addressing will be indirect. Same way, if I talk of STA, then it will store the content of accumulator to memory only. But in this case, if code will be 3, then it will be the direct address. If code will be B, then it will be indirect address. Similarly, all the instructions. Then next, what we were discussed is second type of instruction, that is register reference instruction, wherein as per the format, we are having the 12 to 15 bit fixed, that is 0, 1, 1, 1, that is equivalent to 7. So what we have done over here is these bits are fixed, whereas we are changing into the bits 0 to 11, wherein we are changing. So this is the scenario. So 7800, the first instruction which we discussed was CLA, clear accumulator. Then next we have changed the bit and code becomes 7400, that is CLE, means clear E. The next what we are having is 7200, that is CMA, that is complement AC. Then next is 7100, that is CME, that is complement E. The next we are having is 7080. The instruction which I have mentioned, because we had stopped at this point, I think, if I am not wrong, the instruction is CIR. CIR stands for circular write, circular shift right, accumulator and E. See, circular shift we had discussed into our previous chapter. So circulate write, CIR, accumulator and E. The next instruction what we are having is 7040. See, there is a change in the bit. See the change in the bit. 7040. This is CIL. CIL will be circulate left, AC and E. AC is accumulator and E is our flip-flop. So we need to combine them and perform circular shift left. Next code is 7020, if you can make out. And I am assigning the instruction INC. INC stands for, can anybody tell?
Increment accumulator.
Exactly. Increment accumulator. So 7020 code is for increment instruction, INC, which will perform increment on accumulator register only. Only accumulator register, no other registers. Is it clear? Should I move further? Still we are having more register reference instruction. The next register reference instruction is 7010 and I am giving the code to be SPA, and the meaning of SPA is skip next instruction if AC is positive. See, skip next instruction if accumulator is positive. That means if the content of the accumulator is positive, then skip the next instruction. Are you getting this? All of you? So skip next instruction if accumulator is positive. Is there online? Are you all online? So skip next instruction means what? Over here, say for example, we are having a program of 10 lines, assembly language program of 10 lines, wherein out of those 10 lines, if we write SPA instruction in that, then what it will perform, it will check accumulator. Whether if SPA is written on 5th line, then it will check whether accumulator is positive or not. If it is positive, then it will skip next instruction, means it will skip the 6th instruction which is there on line. It means program mein jo 6th instruction hoga, usko wo skip kar dega and directly it will jump to 7th instruction. So skip next instruction if AC is positive, but if AC is negative, then it will not skip. Then it will execute that 6th instruction, then 7, then 8 and so on. But if SE is positive, then it will skip the next instruction. Same way, similarly, we are having next instruction 7008, and the code assigned to this is SNA. SNA means what? Now you should tell me, huh? Who will tell?
AC is negative.
Yes, exactly. Skip next instruction if AC is negative. Sir, you are just right now mentioning the instructions when we'll be using this instruction. Don't worry, I'll show you the demo program, demo assembly language programs at the end of this chapter, But as of now, in this chapter, we are just supposed to understand the working of instructions. We need to learn the instruction and not the programs. Okay? Next, what we are having is 7004. I am assigning this code to the instruction SZA. Can anybody say what this instruction is?
AC is 0.
So what complete statement?
Skip next instruction if AC is 0.
Absolutely correct. Skip next instruction if AC is 0. Is it fine? Now what about next? 7002 SZE means skip next instruction if E is 0, or E flip-flop. If E is 0, then you need to skip the next instruction, otherwise not. Okay, and the last what we are having is 7001. I have given the code to be HLT, means what? HLT means what? Can anybody say HLT means what?
Halt.
Halt the computer means, suppose I am writing an assembly language program. Suppose assembly language program consists of 10 lines. Then the last line I need to mention that this is the end of my program. This is the program where I need to stop the execution. So I need to make computer to halt. So So that's why HLT I need to write. Like if I say in our C programming, in void main, we start a curly bracket and we close the curly bracket. Why we close the curly bracket? That means we are saying that my program is over at this point. Same way, HLT will give the command to the processor that you need to stop the processing. My program is over at this point. Okay, so this is the scenario. Okay, so the scenario is, these are all the types of register reference instructions. So how many register reference instructions we have discussed? How many register reference instructions? Over here 7 plus these 5. So there are in all 12 register reference instructions as per our system. So total how many instructions? Memory reference 7 and register reference 12. So till now we have discussed 19 instructions in all. Now let's see the third type and the last type of instruction, that is IO instruction. And again in IO instruction, if I talk, IO means input output. So these instructions will interact with our input and output devices. Fine. So for say for example my input device is keyboard. Then if I want to take input from the keyboard, then these instructions will be used. If I want to give output onto our output device, then I can use these output instructions. But very low level instructions are there. That means these instructions will perform the operation at very low level, machine level. Fine. Like what we write scanf in C language. Now scanf will actually call such background instructions, that assembly language instructions. Fine. So input output, again in input output, first of all we need to understand the format of input output instruction, and the general format for IO instruction is this. So you might be clear, you are now clear with why I have skipped the 2 points. Yes or no? Did you get this now? Why I have skipped the code 7 and F in memory reference instruction? Because 7 I have assigned to register reference, and F, that is 1111, I have assigned to IO instruction. These bits will be fixed. Only changing will be this operation, IO operation. So this 4 bits are going to be fixed, that is F, and we'll be changing this bits as what we did in register reference. So let's say we go for this first one. So can I say the code will be F800? So F800, the instruction I am giving to this code is INP. Means input character to AC, means input the character from input device and store it into accumulator register. Fine. Then next we are having, see, I am not going into the detail of these instructions because this instruction we are already going to discuss in later stages of the chapter, because they are supposed to be discussed in detail how they work. Okay, so next what we are having is F400. The instruction given is OUT, out, means output character from AC. Means from our processor we are sending the character onto our output device. Now character, output character means what? Any character it can be. Fine. So output character from AC. Then next we are having is F200. The instruction you will not be knowing and you will not understand also, but just for our reference I am giving, you need to mug this instruction up. That is SKI, stands for skip on input flag. Now skip means skip next instruction on input flag. Now as per textbook they are just writing skip, but actually we are skipping next instruction. So skip next instruction on input flag. So the question will arise, so what is input flag? Now, as we have not discussed input output system of a computer, that's why you are not knowing input flag. So don't worry about it. This will be our next to next topic which we need to discuss, input output. Okay. Next, moving further, next instruction what we are having is F100, and I am giving the code mnemonic to be SKO. अभी आपको पता चल जाना चाहिए SKO means what? Skip on output flag. So again, what is output flag? Don't worry, we'll discuss it. The next we are having is F080, and the instruction is ION. It stands for interrupt on. Now again, question will arise, sir, what is interrupt? Don't worry, that also I'll teach you in the later part of this chapter. So right now, just remember that there is an instruction named as ION. Fine. And lastly, we are having F040, that is what is IOF, interrupt off. Now, in brief, I want to tell you, if there won't be any kind of interrupt system into our computer, then computer will not work. Everywhere in each and every stage, interrupt is always there into your computer. Otherwise, your computer will not work, because it is something based on which our input output devices are working. That's why. It is a concept. Don't worry, I'll teach you. Fine. So, how many IO instructions we have discussed? 6 IO instructions. So totally, as per our complete instruction set, if I discuss, we are having 25 instructions, starting with AND, add, LDA, STA, BUN, BSA, ISZ, CLA, CLE, CMA, CME, CIR, CIL, then INC, SPA, SNA, SZA, SZE, then HLT, then INP, input, INP, then OUT, then SKI, SKO, ION, and IOF. So in all, total 25 instructions we are there, and all the names I have spoken in sequence, which you need to remember, all 25 names along with their working. Because in examination it can be asked that list out the types of instructions. So you need to mention out register, memory reference, register reference, and IO. Is it clear, everyone? All of you, I'm waiting for a reply.
Yes, sir.
Any doubts with this? Please, if you have any doubt, just ask me out. Then I can start up with the next topic.
Yeah.
Now, this is termed as instruction set. We have 3 types of instruction which makes the instruction set. Are you getting this? All of you?
Yes.
So what I wanted to say is instruction set completeness means if I am designing in any of the instruction set, then in that case these category of instructions should be included. If any of them is missing, then my instruction set cannot be said as complete. And the categories of instructions should be arithmetic logic shift instructions, instructions for moving the data to and from memory and processor registers, then program control instructions like SKI, SKO, then SZA, SNA, SPA likewise, and IO instructions. All these 4 category of instructions should be present in any of the instruction set. If any of them is missing, then we can say that our instruction set is not complete. So there should be sufficient number of instruction in each of the following categories. Is it fine? Now we are moving on to one of the most important topic. So all of you, please concentrate on this topic, what I am teaching right now. I will not name the topic, what I am going to teach you. Just we start up with the diagram, block diagram. What is this? You need to be interactive, huh? Please. You need to be interactive to do this. What is this? What is there in front of your screen? Huh? Sorry? Is anyone there in the lecture? अच्छा मैं ही अकेला लगता हूँ लेक्चर में, बाकी सब चले गए. Is Ayush present? Ayush Trivedi?
Yes, sir. It's instruction register.
It's instruction register. What instruction register will hold, Ayush? 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 So is Ayush present? Kevin, can you please mute yourself? Kevin Bamber. Yes, Ayush, are you there? Okay. Someone who can reply. What is this?
Instruction register.
Instruction register. What instruction register contains?
Input output operation.
No. Instruction register. IR. Instruction register में क्या होगा? What we can store? What is getting stored in IR?
Instruction code.
Absolutely correct. Instruction register stores the instruction code fetched from the memory which is to be executed by the processor. Repeating my statement again. Instruction register will store the instruction code fetched from the memory which is to be executed by the processor. Am I clear? Okay. Now I am taking something new in front of you. These are the control logic gates. Don't worry about this right now. Logic gates, control logic gates means there will be some gates available into this block. Have you heard of 4-bit sequence counter? Have you heard of 4-bit sequence counter? Hello. Have you heard of sequence counter word in your digital electronics?
Yes, sir.
What is the work of sequence counter?
Sir, hold next instruction.
Sequence counter. I'm talking of sequence counter. Counter.
Count number.
Increment sequence.
Yes, increment sequences. See, let me tell you, sequence counter which generates the bit sequences. Say for example, I am having a 2-bit sequence counter, then it will generate, just a minute, then it will generate 0, 0, then 0, 1, then 1, 0, then 1, 1. Are you getting this? If it is a 3-bit counter, then it will generate 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, and so on till 1, 1, 1. Is it fine? If it becomes 1, 1, 1, then again this counter resets to 0, 0, 0. Are you getting? This is the working of sequence counter. So if it is a 4-bit sequence counter, If it is a 4-bit sequence counter, then it will generate 0, 0, 0, 0 till 1, 1, 1, 1. Are you getting this? Is it clear, everyone? So this is a sequence. Now once it is 1, 1, 1, 1, again it resets to 0, 0, 0 again. Then again sequence will continue. Once it becomes again 1, 1, 1, 1, again the sequence will continue 0, 0, 0, 0. Is it fine? This is the working of sequence counter. Now I am taking one decoder, 4x16 decoder. Now you should tell me what is the working of decoder. Someone please tell me. What is the working of decoder? Oh, hello. लगता है I find out that people have decided not to speak anything in the lecture to maintain pin drop silence. Is it?
To change the opcode to
No, decoder. I am talking of decoder. What is the work of decoder? So what is the work of
which
decoder?
the code into a signal?
No.
An
It
input
take,
to the output.
Yes, yes.
it take less input and give more output.
No, I cannot say like that.
2
Okay, sir.
2 raised to n combination.
See, the decoder circuit size will be always n cross 2 raised to n size.
सर वो एक सर्किट है जो कोड को सिग्नल में चेंज करती है।
ऐसा बोल सकते हैं हम, लेकिन कैसे होगा? सपोज मेरे पास ये 4-bit डिकोडर का इनपुट दिया. आई एम हैविंग 4-bit डिकोडर इनपुट. Say for example, over here I am giving 0, 1, 1, 0. Understand it in reverse. Okay, consider 0, 1, 1, 0. What is the decimal equivalent of 0, 1, 1, 0? Decimal equivalent of 0, 1, 1, 0.
6.
6.
That means on the 6th line output of the decoder. See, I tell you, on the 6th line, 6. On the 6th line output of the decoder, one output will be there. You will be getting the signal 1. Rest all the bits will get 0 output. Is it fine? Yes or no?
yes.
Okay. Now again tell me. If I give 0, 0, 0, 0 as an input to the decoder, what will be my output? मैं यहाँ पे 0, 0, 0, 0 देता हूं, तो what will be my output? Can I say my this 0th line will be 1, rest all line will be 0?
Yes.
Yes, sir.
Sequence counter
Yes, sir.
में next input हो गया 0, 0, 0, 1, तो क्या होगा? Next input 1 will be 1, rest all will be zeros. So this is what I will be getting the output. T0 to T15. So पहले T0 आएगा, फिर T1, then T2, then T3, T4, T5, T6 till T15. Is it fine?
Yes, sir.
So this is nothing but your clock. देखो साइकिल हो गई ना अभी, पहले T01 होगा, फिर T11 होगा, फिर T2, T3, T4, T5, T6 टिल T15, और जैसे ही T15 1 हो गया वापस T01 हो जाएगा. Yes or no? Can I say it exactly works like our clock? Whatever we see into our clock, after 60 seconds, it starts from 0 to it reaches to 59 seconds, it again becomes counter becomes 0. The same thing, can I say I have created a clock into our processor? Yes or no? Should I move further?
Yes, sir.
Now I am taking one more decoder. 328 decoder, to which I am giving input 3 bits of input from IR to this decoder, which gives 3 to 8 n cross 2 raised to n. So 3 to 8 decoder, I would be getting 8 output lines from this, which are connected to again control logic gates. And then later on, again 15th bit is connected to I flip-flop, direct, indirect, and again given to logic gates. Now you have to tell me from this, how this circuit is going to work. Sir, अभी हमें कैसे पता रहेगा? Now, say for example, in instruction register, in instruction register, I am having a bit. See this. This is the instruction into my computer register. IR. IR consists of these bits. What is going to happen? Can anybody say? What is the working of this decoder? What is the working of this decoder? What is over here given as an instruction register contains 001. So what will be the output of this decoder? 328. 001 means what is the decimal equivalent of 001?
1.
1. So can I say my D1 line will be 1? Rest all will be 0. D0, D2, D3, D4, D5, D6 and D7 all will be 0. Only D1 will be 1. Yes or no?
Yes, sir.
Yes, sir.
Now you have to tell me which is this instruction. ये कौन सी instruction है? ये कौन सी instruction है? ये 0001 किसका opcode है?
Add.
Absolutely correct. Add instruction. 0001 means hex code is 1 and it is add instruction. So can I say whenever add instruction will come, D1 line will be 1?
Yes, sir.
Are you getting my point now? Now say for example, I make a slight change, or I should not say slight change, a major change. Instead of this, I am writing 0, 1, 1, 0. Rest all bits as it is. Which this instruction, okay, before going to that, what will be the output of decoder? Please, what will be the output of decoder if I give 0, 1, 1, 0? Sorry?
D6.
D6.
E6, absolutely correct. So I will be getting the output from line D6. Yes or no?
Yes, sir.
So what is this instruction 6 code is assigned to? सर अभी ये कैसे याद रहेगा? 6 is assigned to ISZ if you remember. So what it is meant to say that whenever computer processor will encounter ISZ instruction, at that time D6 line will be 1. Rest all will be 0. Did you get this now? Did you get the working of this decoder, this 328 decoder? Okay. Now tell me once again, you have to tell me, what if I give instruction bits to be 0, 0, 1, 1, 1, 0, 1, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. What is this instruction? First of all, tell me the hex code.
7.
7, then
800.
check it out carefully.
7400.
7400.
7400.
Absolutely. 7400 means 7400 means which is that instruction?
Clear E.
Clear E. Absolutely correct. But what will be the output of this decoder? If I give this, then what will be the output of this decoder? Which line will be 1?
D7.
D7, absolutely correct. But does that make out which is this instruction? In earlier cases, we were able to make out add instruction as well as ISZ instruction. But are we able to find out the CLE instruction over here?
No.
No, because over here, this will state you that D7 line is 1. That means it is one register reference instruction. Yes or no?
Yes, sir.
But again, the problem remains as it is. Okay, let me change the code. Instead of this 0, I am making it to be 1. Then, which is this instruction? Can I say it is F400?
Good out.
So F400, which is IO instruction.
Yes, sir.
Okay, what will be the output of this decoder in this case? Which line will be 1?
I.
I is 1. No, I'm talking of decoder. Decoders, which line will
D7.
be? D7. So can you make out in register reference also D7 was 1? In IO instruction also D7 is 1. Am I correct? Yes or no? All of you?
Yes, sir.
Then how computer will decide that whether it is register or IO? That will be decided based on this I bit. Okay? If it is all 3 bits to be 1, then D7 will be 1. That means it is meant that it is the meaning D7 means 1, means either it is register or IO instruction, but for sure it is not memory reference. Is it clear? But now whether it is memory or register, it will be decided based on this I bit. If this I bit is 0, then it will be register reference. If this I bit is 1, then it is IO instruction. So did you get this? All of you?
Yes, sir.
this is how computer will decode which instruction is there came in for execution. Is it fine? And this is what is termed as control unit of basic computer. Still some part is missing in this, don't worry. This is controlling. Based on the instruction coming into the IR, it will control your other operations through these control logic gates. Okay, fine. So today we stop here. In next lecture, we'll be discussing further. Roll number 1,
Present, sir.
2. Roll number 2,
Yes, sir.
4. Roll number 4, absent. 5. 5, absent. 6.
Yes.
8.
Present, sir.
9.
Present, sir.
10.
Present, sir.
11. 11, absent. 12.
Present, sir.
13.
Present, sir.
14. 14.
Present, sir.
15.
Yes, sir.
16.
Yes, sir.
19. 20. 21.
sir.
22.
Yes, sir.
23.
Yes, sir.
24.
Present, sir.
25.
Present, sir.
26. 26. Absent. 27.
26 present.
26 present. 27 present. 28.
Present, sir.
29.
Yes, sir.
32.
Yes, sir.
33.
Yes, sir.
34.
Present.
35. 35. Present.
Yes,
30,
sir.
36.
Present, sir.
37.
Yes, sir.
39. 39. Absent. 40. 41. Sorry, 42. 42.
Yes.
Absent.
Yes, sir.
44. Sorry,
42.
present. 43.
Present.
43 present. 44.
Yes, sir.
45.
Yes, sir.
46.
Present, sir.
47.
Yes, sir.
48. 48. Absent.
Present, sir. 48.
49.
Yes, sir.
51.
Present, sir.
52.
Yes, sir.
53.
Present, sir.
56.
Yes, sir.
57.
Yes, sir.
58.
Present, sir.
59. 59. 59 absent. 60.
Present, sir.
61.
Present, sir.
62.
Yes, sir.
63.
Yes, sir.
65. 66. 66. 165.
Present, sir.
178.
Sir, 125, sir.
Huh?
125.
Sir, 178. 178, sir.
104.
Sir, 149.
Sir,
I am,
161.
I am taking attendance. One zero four.
Present, sir.
113.
Present, sir.
125,
Yes, sir.
149,
Present, sir.
161,
Present.
165,
Present, sir.
178,
Present, sir.
D2,
Present, sir.
26, 26, absent, 27,
Present, sir.
28,
Yes, sir.
29, 29, absent, 30, 30, absent, 31, 31, absent, 32, 32, absent, 33,
Present, sir.
34,
Yes, sir.
35,
Yes, sir.
37,
Present, sir.
38,
Present, sir.
39,
Present, sir.
40, 40, 40 absent, 51,
Present, sir.
1, number 1,
Yes, sir. Present.
2, number 2, 92020103002, absent. Anybody left out? Okay, thank you all of you.
Yes, sir.